So now we're going to talk about what happens if you have an exponent that's 0. First of all, I want to go over when you just have like x and you don't see an exponent, that's a 1. Now we already talked about that. That means you just have x to the first power. All right, but now we're talking about, well, what if you have x to the 0 power? All right, the best way I can think of to explain this is, let's say you have x to the 4th over x to the 4th. Now, if you think about that, the numerator is the same as the denominator, right? Well, that's just going to be equal to 1, right? When you have a over a, that just equals 1, right? Okay, so that's something we've probably had in our past math. But the rules of exponents say, wait a minute, what if I used my quotient rule and I subtracted? I'd have x to the 4 minus 4, or x to the 0 power. So by definition, x to the 0 power has to equal 1. So if I have some base to the power of 0, that equals 1. Now that's the rule, and we'll give you some examples and hopefully answer any questions you might have. But if you have a base to a power of 0, that just equals 1. All right, so this is kind of like the a is kind of like the example I was just doing. So c cubed over c cubed, 1. You know, you can think about all the c's canceling, but it'd just be 1. Now, part B, what is being raised to the 5th power in the denominator? X to the 5th, right? And what's being raised to the 5th power in the numerator? Just the x. That negative 3 is not being raised to the 5th. If they wanted it to the 5th power, they'd have to put parentheses, and they didn't. So this part, that's just 1. And so you have negative 3 times 1, or just negative 3. Now you might be saying, but you didn't show a 0. Okay, so you could have said negative 3 x to the 5 minus 5, or negative 3x to the 0, and then that part's 1. So then I still get my answer there, negative 3. Okay? All right. Now what have I got going on here? I've got a base that's j squared k in all of these cases. Every set of parentheses has a base j squared k. The only thing that's missing is I don't have that 1, like right there if I want to see that. So in the numerator, I have j squared k to the 4th power. And then in the denominator, I'm multiplying here, right? So add those exponents, the 1 and the 3. And I have j squared k to the 4th power. Now right there, you can say, oh, it's 1. But if you want to see the 0, you could say j squared k to the 4 minus 4, or j squared k to the 0 power, which would just be 1. Okay? All right. And then our last one here, you probably can see it. I don't know, it's kind of visual. And sometimes it's hard to, you have to train your eye to kind of look at the whole picture. You've got a base here, rs squared, and a base here, rs squared. So then you've got that exponent and that exponent being subtracted. Which is 5 rs squared to the 0 power. Now, whatever's being raised to the 0 power, this part, that's just 1. So then it's 5 times 1, 5 times 1, however you want to write that. Anyway, and that'll just be 5 for the answer. Okay? So it's a little tricky with the 0, but you can do it.